All right, let's tackle some problems involving reasoning with reference angles. And these are good problems because they're a little more conceptual. They don't require calculators, and they'll help you understand the unit circle better. So just as a reminder, if you're coming to this video, just like a quick primer on how I'm going to talk about these ideas. When you think about trigonometry using the unit circle, if I can get a circle drawn, there we go. Right, so again, in order to do these problems efficiently and reliably, you will want to know how we're using the unit circle and defining our trig functions in terms of the unit circle. So for instance, if that's angle theta, an angle in standard position, this is the point x comma y. Remember, it's the unit circle, so that's a 1. We can see by definition cosine of theta is equal to this point here. That distance there is the x coordinate. That's the y coordinate. It's x over 1, adjacent over hypotenuse, which is x, and the sine of theta is equal to the y coordinate over 1, opposite over hypotenuse. So that's y, which means I can rewrite this point as cosine of angle theta, comma sine of angle theta. Two ways of representing that point. And then the last thing to think about is that because tangent is opposite over adjacent, tangent of theta equals the y coordinate over the x coordinate. That's also the slope of this line. Okay, so the slope of this line, I'm going to extend it. The slope of the line is rise over run, but the rise is y and the run is x. That's also the tangent of angle theta. So let's see if we can use that idea to do some of these problems. This is a non-calculator type of exercise. We're given that sine of 40 is some number a, cosine of 20 is b, and tangent of 80 degrees is c. And because of that, I'm able to express these. Again, these are all rigged to be able to be done with the information provided. We're expected to be able to express these in terms of a, b, and c. So let's start with sine of 320 degrees. So 320 degrees looks like this. You rotate almost a full 360, but you are just shy 40 degrees. I'm going to zoom in on this. So I rotated 320 degrees. I am 40 degrees shy of 360. By definition, this point has coordinates cosine of 320 degrees, sine of 320 degrees. Now, I don't know information about the sine of 320 degrees. What I do know is that the sine of 40 degrees is a, but 40 degrees would take you here, and sine, again, we're in the unit circle here. Sine is the, well, let me label the points. That could be considered cosine of 40 degrees, comma, sine of 40 degrees. And so we note that this point right here, right, its coordinates are cosine 40, sine 40. The coordinates here are cosine 320, sine of 320. Notice they both have the same x coordinate, right? But their y coordinates are opposite. This is the opposite of that. Just based on the diagram, we can see those y values are identical but opposite, identical in absolute value but opposite. So that means that the sine of 320 is the opposite of the sine of 40 degrees, but the sine of 40 degrees is a. So this answer would be negative a. Let's try the cosine of 160. So 160 takes us here, just shy 20 degrees. Just shy 20 degrees of 180. This point right here can be thought of as the cosine of 160 degrees is its x-coordinate, and its y-coordinate is the sine of 160 degrees. Okay, so what does that tell me? Well, it tells me that this length, right? Again, we're gonna use this reference angle here to make a new triangle. That must be 20 degrees, right? Now we know something about the cosine of 20 degrees. We know that that's equal to b. And just kind of just for space, I'm going to get rid of that for a second. 20 degrees would take us here. This point here has coordinates cosine of 20 degrees, sine of 20 degrees. We're given that the cosine of 20 degrees is b. Right? We know that that's b. That is this distance right here, right? That's b. How does that relate to this distance here, which is the x-coordinate, right, of this point, which is the cosine of 160? Well, it's the opposite of b. So therefore, cosine of 160 is the opposite of b, which is the cosine of 20 degrees. So we write cosine of 60 equals negative b. Let's try this one, tangent of 260 degrees. So 260 degrees brings you, I'm not going to draw the line because it kind of gets in the way. It's just, so this is 90 degrees. This would be a rotation of 180 degrees. This would be 270. So you're just 10 degrees shy of 270. So it looks something like this. Okay, so what we're talking about the tangent, right? So the tangent, how does it relate to this line here? It's the slope. So the slope of this line is equal to tangent of 260 degrees. Now I'm not given 260 degrees up here. I'm not given that information, but I do know that if I just extend this line here and keep going, right, that's the same line, so it has the same slope. But let's express the slope of that line, not in terms of tangent of 270 degrees, but let's try to get in play this 80-degree angle. Let's see if that emerges anywhere. Well, like I said, if this angle that lends you here is 260, that must mean that, well, it means this is 10 degrees, right? Which means that that's 10 degrees, right? Because they're vertical angles, which means this is 80 degrees. So if we think of this this angle here, the slope of this line, the blue one, which happens to be the same as the green, is equal to the tangent of that angle in standard position, which is 80 degrees. So in this case, they're equal, right? These are exactly the same. So we can say, but tangent of 80 degrees is equal to c. So tangent of 260 degrees is equal to c as well. And just a couple more. Let's see, sine of 140 degrees. Let's try that one. So 140 degrees takes you just 40 degrees shy of 180. So it take you something like this. It looks something like that. So if this angle that you just rotated, let's do it like this. If that angle there is 140 degrees, that must make this reference angle 40 degrees. And again, this point right here has coordinates cosine of 140 degrees, sine of 140 degrees. Sine is the y-coordinate of that point, which means it's this signed distance here. How does that relate to the info given? We're given that sine of 40 is a. So let's see if we can figure that out. 40 degrees would bring us here. Right? It's like a symmetric picture, symmetric over the y-axis here. Thinking of that as 40 degrees, remember this point right here in red has coordinates cosine of 40 degrees, sine of 40 degrees. So we draw our attention to the fact that the y-coordinate is sine of 40 degrees. That's this length. That length is identical to this length here. But the length on the right is sine of 40, which is a. And the one on the left is sine of 140, which is what we're trying to express in terms of a, b, or c. Since they're the same, we know. So I'm just going to write it this time. This is the same as the sine of 40 degrees because their y-coordinates are identical, which is a. And we finish with this one. This is the cosine of 700 degrees. So 700 degrees is coterminal with an angle in between 0 and 360. So to get that angle, and that's coterminal, we're going to subtract 360 degrees. So this equals cosine of 700 minus 360 degrees, which is equal to the cosine of 340 degrees. Okay, with the cosine of 340 degrees, so 340 degrees brings you just 20 degrees shy of 360. So it brings you here. All right, that's 20 degrees, the reference angle, that is. So this has coordinates cosine of 340 degrees, comma, sine of 340 degrees. Now, we're interested in the x-coordinate here, cosine of 340. How do we express that in terms of info given? We are told that the cosine of 20 degrees is b. If we rotated 20 degrees, that would put us here. So this point here has coordinates cosine of 20 degrees, sine of 20 degrees. We know that this is given as b. So how does this, so again, cosine is the x-coordinate. Let's just kind of draw the right triangles in. The x-coordinate of this point is cosine of 340 degrees. The x-coordinate is that length. That happens also to be the same as the cosine of 20 degrees. So these are equal. So the cosine of 340 is equal to the cosine of 20, which was b. Okay, so this exercise is good because it draws your attention to the symmetry in the unit circle. It reminds you that any point on the unit circle can be expressed as cosine and sine of the angle that brings you there. And it helps you think about where x and y coordinates are positive and negative in order to express identities that are actually true.